Hello and welcome to our latest nugget for the social distancing videos. My name is Solal. I'm a customer success engineer out of the EMEA office. And today I want to talk to you about the topic called OPA and Oma went on a walk, or in other words, how defenders act as admission controllers. So Prisma Cloud provides a dynamic admission controller for Kubernetes that's built on the Open Policy Agent, or OPA. In the Compute Console, you can manage and compose rules in Rego, which is OPA's native query language. Rules can whitelist or blacklist, which means alert or block pods. Console pushes your policies to Defender, which enforces them in turn. Decisions are then made by the system, are logged. OPA is an open source general purpose policy engine that lets you consolidate policy enforcement in a single place. OPA can also enforce policies in microservices, Kubernetes clusters, CI/CD pipelines, API gateways, and so on. So OPA provides a high-level declarative language called Rego, which lets you specify policy as code. The OPA API lets you then offload policy decision-making from your software. Prisma Cloud operationalizes OPA by first extending console to manage and compose policies in Rego. Second, integrating OPA's decision-making library into the defenders, and connecting defenders' enforcement capabilities to OPA's decisions. So you can create policies for OPA directly from the Prisma console UI and implement those policies with an admission controller. Policies can then be created and managed within the access control policy engine and then stored in both console and Defender. Then an admission controller is code that intercepts requests to the API server in Kubernetes for creating objects. There are two types of admission controllers, built-in and dynamic, but just for today's focus, Prisma Cloud implements a dynamic admission controller that are basically built as webhooks. So what you'll need to have is a running instance of Prisma Cloud Compute Console, Kubernetes cluster, minimum supported version is 1.13, so 1.13, and Defender has been deployed on your cluster as a daemon set. So those are the prerequisites. What we'll need to do is to change the advanced settings of the defenders, either from the defenders manage pane or when enabling the admission feature. We will then copy a YAML file into the Kubernetes cluster and edit it, and we'll create a webhook configuration objects. Once we do that, we'll then validate the setup. So to go through that, I'll show you how to enable the advanced settings from one place directly, from defend and access. We will find a new feature, admission. Once I enable that, I can immediately see the built-in rules for admission controls based on Rego language that we developed in-house and out of the box. And you can develop and create more rules based out of those. When we do that, we also need to go to the advanced settings of the defenders, which can be directly accessed from here. Or if you really want to, you can also directly go to Manage Defenders. Under the Manage Defenders page, you have advanced settings. But we're already here, so we can edit that from here. What we'll need to do is let the defenders know that they need to have an admission control webhook. So what we'll do is we'll copy the configuration here. We'll then go to our shell, and we'll need to create a new YAML file, a new configuration file with the webhook. So I already have one in place. I copied it in, and we need to add it two fields. The first field we need to edit is the namespace. We need to make sure we put the namespace of the defenders daemon set. The second field we need to edit is the CA bundle. That CA bundle is available from the Defender daemon set YAML file you downloaded when you deploy the defenders. It will be found over there under the ca.pem field. Once we copy it here, all we need to do is just create it. So we can do kubectl apply -f and webhook. kubectl apply -f and webhook, small typo. And we now have the validating webhook configuration for admission control. That is called TW validating webhook based on the YAML file we created. And what we need to do next, we can validate the deployment. So to validate it, we can create a pod, an example pod. And just to see that one of the rules we have are actually auditing the issue, we'll take the first rule, call it CIS check for privileged pod creation. So we do not allow privileged pods to be created. So just taking a quick look at one rule example with Rego language in it, we have the rule name, rule description, a flag of whether we want to skip the raw data of the actual API in Kubernetes when we log it as an audit. And what is the effect? Do we want to whitelist it, just alert it, which is the default, or even block it from happening? So quickly looking at the Rego language, which is also highly documented, so that can be referred to later. What we're looking for here is the create operation of a pod, and the resource kind is a pod, and we are looking inside the YAML file when it's created, if in the spec containers, it's being created as privileged. If so, I want to print out a message, in this case, privileged pod created, so the user can see what happened. So in this case, I'll also change it to block so we can see the effect. So let's update the rule. Now that it's updated, let's have a quick look at a quick file that I have. I think it should be called privileged. So let's look at privileged. So this is just a spec for creating one pod from Nginx, and we also have the privileged flag equals to true. So what this YAML file will try to do when we deploy it is try to create a pod which is privileged. So what we'll do is kubectl apply -f and privileged. Now that we try to create it, it will immediately fail. And we have an error from the API server basically saying admission webhook denied the request, privileged pod created, which is the error that we set in the rule over here. Now, except for blocking it upon creation, so the pod wouldn't have been created now with the admission controller, we also got an audit in Prisma Cloud Compute. To see that, we can go to monitor events, and then under admission audits tab, we can find the recent audits. And now based on the time and the location, we can see that we have a new audit ran by the specific user who tried to create the pod. And we have the message that the user also got on the UI, which is privileged pod created. And then the effect was we blocked it. So what the user had is also a blocking. He couldn't create a pod. The operation was create of a pod in the namespace default, etc. Now, if you click it, we can see all of those details and also the raw request from the API server in Kubernetes to actually create the pod with all of its specs in it. So this is the actual event that you can see from Prisma Cloud Console. And the way the user is affected and fills it once admission controls rules have been set is seen here. So that basically is our biggest, one of the biggest features we released in 2004, which lets you have defenders act as OPA for deployed Kubernetes admission controllers. With that said, that is all for our new feature, and I hope you enjoyed it, and see you in the next nugget.